So far we've considered wind and string instruments, which make really nice noises that we consider to be music. So what we're going to look at now is some different types of percussion instruments. Percussion instruments can actually be quite a lot more complicated to understand, at least in how they play the exact note that they play. The basics is just that when you hit something with a stick, you start it vibrating, which makes the air particles vibrate, and that's the sound that we hear. But if we want to work out what the frequency of that sound is, it becomes more complicated. So one of the simpler instruments to understand is a Glockenspiel, like this one here. Or possibly, you've seen toy ones of these, like this cow one here. So how can we work out what frequency those notes are when they're played? Well, the equation for the frequency is quite complicated. The frequency is given by pi times the speed of sound times k, which is the radius of gyration for the object, which is related to its moment of inertia, which we'll learn about in later courses, divided by 8L squared, where L is the length of the bar on the Glockenspiel, times M squared, where M is the mode. So M is equal to 3.0112, so almost 3, and then it goes up in 2, so 5, 7, 9, etc., with 2M plus 1 giving the modes. So the Glockenspiel doesn't have harmonic overtures because of that M squared term. The natural frequency goes up as M squared rather than as M, as it did in the standing waves on the strings and pipes, where the natural frequencies were all integer multiples of the fundamental frequency for that note. Okay, so let's look at this Glockenspiel in a bit more detail. Proper glockenspiels consist of a metal bar over the top of a resonating cavity. So the resonating cavity here is here to increase the intensity of the sound. And as you can probably see, the metal bar is supported on two little supports here. Now, when we hit the bar, we're actually setting up a transverse pulse in the bar. So the bar is moving like this. At the supports, we've got nodes. So if we imagine having a rod and clamping it at certain positions, wherever we clamp it, we're going to end up with a node. It can't move easily at those positions. So that's what happens in this Glockenspiel here. So this is one of the C's on the Glockenspiel, and the other C is here. So these are 1 octave apart, which means that the frequency of this one is double the frequency of this one. So we can just use this to check our formula a little bit. Here I've got a ruler, and if I measure the length of this C note, it is 12.8 centimeters, and this shorter C note is 9 centimeters long. So if these are both C notes 1 octave apart, then we'd expect that the frequency of this one divided by the frequency of this one should be 2. And looking at our equation, if we hit them both in the middle, we're exciting them both in that first mode, and so the only thing that's different between these two is the length of the rod. So we can substitute that into our equation. So the frequency of this one divided by the frequency of this one is going to be equal to 1 on 9 squared, because this one was 9 centimeters long, divided by 1 on 12.8 squared. And you can see, putting that into the calculator, that that is 2. So these are 1 octave apart. Okay, so the Glockenspiel is a nice example of setting up standing waves in rods. A xylophone is even more complicated to understand than the Glockenspiel. With the Glockenspiel, the rods are made from metal and they're just straight bars. With the xylophone, there's actually little hollows cut out of the bottom end of the bar so that they look like this. And the reason this is done is to change that radius of gyration, the K in the formula, which lets the lengths of the xylophone bars be changed. Now, how to calculate the frequencies of glockenspiels and other percussion instruments isn't going to be covered in the examination for this course, but it's just been included for you as a bit of background information. So possibly you will have students who are very interested in music and want to look into this type of thing for depth studies. Remember, you can use the program Audacity to record the frequencies of the notes, and you can have the students measure the length of the bars on the glockenspiel or similar instrument, so they could investigate that formula that we've presented for the frequency of the different glockenspiel notes.